So what I did when I started writing this book, because I wanted it to be accurate, was I found the guys in the IRC room that were disagreeing with me the most readily. The
Mhm.
ones who were always going, well, actually, to everything I said. And I said, here, edit this.
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes.
Hey listeners, stay tuned for a very special announcement at the end of this episode. Enjoy!
I am here today for this episode of the LabVIEW Experiment with Jason McDonald.
Hello.
You may recognize him. I appeared on a podcast called The Bug Hunters Cafe a little while ago, and Jason's the host of that, along with Bojan. I don't remember Bojan's last name off the top of my head.
Bojan Miletic.
Miletic, okay. And Jason also runs MousePaw Media. He wrote a book recently that we'll talk about. He's also involved in something called Quantified Tasks. So this is a little outside of our normal realm. Jason is not a LabVIEW programmer, but I think there's some interesting stuff here that may be of interest to our community. So in the spirit of trying to bring in outside influences, I think we're going to have a great conversation. So let's just start with the Bug Hunters Cafe. Why don't you talk a little bit about that? Because I quite like that podcast.
Oh, thank you. Yeah, that started back during the pandemic because I was, as an author, I spend most of my time writing in coffee shops. That's where I am most productive. So I actually spend half of every workday sitting in a coffee shop, just, working remotely. So I've always liked that environment because you catch snatches of conversation. It's just kind of got this general busy sort of atmosphere without really being overly distracting. And I've always enjoyed that. So in the middle of the pandemic, I was really missing sitting in a cafe, overhearing conversations and chatting with people. And I began thinking, well, I know a lot of people that kind of have a similar thing where it's like they just miss social contact. And so I thought, wouldn't it be fun if there was a podcast that was set in a cafe? Purportedly anyway. So you're, instead of it just being a clean recording of two people talking, it sounds like you're overhearing it at the next table. So I contacted my good friend Bojan Miletic, who had introduced me to this whole idea of virtual coffee, basically just making random appointments with different people on LinkedIn or whatever, saying, hey, you want to get some virtual coffee? We'll just talk about whatever. And it's a great way of getting to meet people. And I said, hey, I get this idea for a podcast and we can talk about, since we're going to be different, instead of talking about everything that goes right in software, let's talk about everything that goes wrong. Let's talk about all the mistakes and the bugs and the disasters and the gotchas, and have us set in the cafe. He said, yeah, that sounds awesome. Let's do that. And that's where the Bug Hunters Cafe came from.
Cool. So one of the things I like a lot about your podcast is kind of the whimsical nature of it. Like, it doesn't take itself very seriously. Like, you talk about serious topics, but in the background noise and some of the magical, mystical nature of it, I think is it's kind of refreshing, because like some podcasts are very like cut and dry and very technical, and yours is just kind of just nice, friendly conversation. It's very easy listening.
Well, I mean, I think it helps that I don't take myself terribly seriously. If you don't notice there, if I tilt my camera, I've got, Twilight Sparkle sitting on the shelf behind me here.
Wow.
Right above that is the TARDIS, which tells you everything you need to know about me. Tilt that back down. But I've always loved stories and just imagination. And I mean, one of my other things I do is I write fiction. So I've always appreciated good storytelling. I've always appreciated just whimsical things. Bojan and I actually kind of share a love of unicorns. That's how the unicorn showed up.
Oh, okay.
Yeah. Like, there needs to be a unicorn there. Yeah. So, but for me, software engineering always was kind of a second fiddle to my storytelling, my creativity. So If anything, the only reason I ever picked it up in the first place was because it was a means of telling stories. And love for software engineering kind of grew out of that. But like the whole reason it was in my world is because I wanted to make games. And I enjoy a good story. I think the day that one stops being imaginative, whatever flavor that takes on for you, the day someone stops being imaginative and everything just becomes that sort of cut and dry and professional and NPR voice, which has its place. But when that's all there is anymore, I think that's the day you stop growing and start aging. Because some of the greatest people I've known have been very imaginative people who are, you'd say, getting up in years, but no one ever gave them the memo. They're still enjoying life, but their imagination just kind of permeates everything.
Yeah, that's really interesting because I feel like as engineers, particularly software engineers, we tend to lose some of that magic, right? Like to me, especially like writing code in LabVIEW is magic because like I type in a few lines of code and it's kind of at that hardware level where you can like see lights blink and motors turn and things. And it's like, what's the thing like technology, the best technology is indistinguishable from magic or something.
Mm-hmm. Yeah. Sufficiently advanced technology is indistinguishable from magic. Yes. Yeah. I mean, that's for me, there was kind of that magical moment when I first picked up code. Just that moment where I typed in a line and there was a dialog box that popped up. And just the thought that ran through my head is like, that's not just a dialog box. That's my dialog box. I made that appear. And that moment of, wow, I'm powerful. I can make the computer do things. That's when I fell in love with it.
Yeah.
Yeah.
So speaking of creativity and coding, I heard this quote, and I may have used this on the podcast before, but I'll repeat it. Something about how we think when we're writing code that like as we're adding code, we're like building the sculpture like out of Play-Doh. But what we're really doing is we're building the raw material, we're building the block of marble, and then we chisel away at it to get the masterpiece underneath. That like coding is more about like, because it's one of those things, if you've ever, there's a quote, and it's probably not Mark Twain, but it's attributed to him. Something like, I would have written a shorter letter, dear, if I had the time, right? Like, it's easy to just throw stuff at the wall. It's really hard to mold it and get that shape that you want and be short and concise and easily readable. And
oh yeah, no, it's I agree. I make no secret of the fact that I'm a 3-time traumatic brain injury survivor. And one of the things I lost mostly with the second TBI and the rest of it went out with the third was something called inference. So the human brain has basically 3 forms of reasoning. You have deductive reasoning, which is specific and a specific leads to another specific. You have abductive, which is a general and a specific leads to a specific. But then you have inductive reasoning. And inductive reasoning goes the other direction. That takes a few specifics and goes out to a general conclusion. This goes by varying names. Inference, pattern matching, assumption actually runs out of this. Bias runs out of this. It can both be a very good thing and a very bad thing. But my brain is no longer capable of that inductive reasoning. It just, the hardware is gone. So I've learned ways of compensating with deductive and abductive reasoning. Most people, when they hear that and know me, are like, I can't tell. I mean, are you sure? How do you know? It's because I live in this brain. Believe me, I can tell. It took me enough years to figure it out because I can't infer. So, I have to get all the clues in place to figure things out. And where was I going with that? Yeah, and now I remember what I was going to say. So inference is also the way that we figure out what we can leave out, because those implied messages when you're like talking to another person and you leave out part of your message, your whole message might be something like, I had a really good time on my vacation last week. And you might say to the other person, I had a good time last week. you don't mention your vacation because it's implied that you had a great time because you were on vacation because the other person knows you're going on a vacation last week. So there's this implicit ability to leave out parts of the message and the other person understands. For me, that doesn't occur anymore, which means I have to stop and think about, okay, what does the other person know? What can I leave out of this? Which, as a result, means that I tend to write and speak long form first, and then I have to go back and revise. And this is why Dead Simple Python is an 800-page book.
I was going to say, it is a very detailed book.
Yeah.
It actually, so it does read very well because your whimsical nature does come through. And also, you were very good at calling out the little pedantic notes I thought were really funny.
Yes.
Because that was like the detailed part of your brain being like, this detail's not important to what they're doing, but I can't let it go, so I have to write it down. And so I get that sometimes too.
Actually, those pedantic notes were not there for me. Those were because I learned Python from the Python IRC channel, which is currently living in Libera, if anyone wants to go find that. But that's where I learned Python. And the guys there tend to be, well, Python developers in general tend to be really pedantic, really exacting. It's like, well, that's not exactly it. It's like a slightly different shade of orange. They will micro correct you. And to a large degree, that's actually very helpful in software engineering because Python's all about like the one right way, right? You know, that's what we talk about. But when we say the one right way, that doesn't mean that we necessarily know what it is. It means that we want to find it. So we're always looking at optimizing everything we're doing, and so that kind of leads to that mindset. So what I did when I started writing this book, because I wanted it to be accurate, was I found the guys in the IRC room that were disagreeing with me the most readily, the ones who were always going, well, actually, to everything I said, and I said, here, edit this. And they did. They did a marvelous job, but those pedantic notes were kind of coming from them. It was like, what?
Oh, so that's not you. Say, okay, that's them.
It's them, and all the little arguments that would kind of, there would be proxy arguments between the editors. You know, it's like because one person would be saying A and the other person would be saying B, and I'd have to be going back and forth between them. It's like, okay, well, justify this, and finally would lead to my saying, well, it's generally A, but technically.
Yeah, I always struggle with that when I'm teaching. Like, how far into the weeds do I need to go? Like, you know, okay, I understand the very lower level workings, but do you really need to understand it if you're just trying to use it? And what, like, when does the abstraction leak, and when do you actually have to care about what's going on underneath, and when can you just kind of let it go?
Yeah, I mean, I guess it depends on the skill level of the person you're talking to. I mean, Python is not written for a first time coder, of course, because there's plenty of books for that. Sorry. Dead Simple Python is not written for a first-time coder because there's plenty of books for that. It's written for people who already know coding to some degree and are picking up Python maybe for the first time, or they're wanting to get really good with Python. So that's kind of one of the reasons I'll go into the weeds more. But one of the things I've learned from training interns over the years, I would explain something in minute detail sometimes, and I would always preamble it by saying, now, I'm not expecting you to remember this, but I'm going to give you some insider information into this concept, because the next time you hear this, it's going to connect back to this moment. Because usually the first time we hear something, it goes in one ear and out the other. The second time we hear it is when it solidifies. Well, my general thought is the first time you're hearing it from me, you probably don't need it right now. The next time this comes up, you're really going to need it. So if I have gone ahead and cut that initial trail, that initial synaptic path for you, then the second time you hear it, it's going to stick. And you're going to go, oh, that's what's going on under the hood. It's a little bit like someone teaching chemistry and, you know, going through the whole, you know, where electrons are in the atom. And it's really tempting to just say, oh, yeah, there's the little, you know, levels of orbit and whatever, and show the Bohr model, which is so horrifically wrong that students who learn that, they get to college and they have to unlearn the whole thing, which proves to be less than helpful. A good chemistry teacher, a good high school chemistry teacher, will say, now, I'm going to show you something that is super simplified. Understand, however, we don't know where an electron is at any given moment. So this is just our best guess of where an electron is. They don't orbit like little planets. But because it's a really complex thing and we're just learning about electrons right now, I'm going to really simplify this model for you.
Mm-hmm.
Then you introduce the Bohr model, and now it's serving its purpose. It's a simplified model, helps them get an initial grasp on it, but they have that little asterisk floating in their head going, there's more detail here than teachers going into, and I'm going to have to wrestle with that later.
Yeah, no, sometimes I will plant little details and be like, just so they put it in the back of their mind, so that then later they're like, oh, now I remember he said this thing here is a little bit different or something. So yeah, that I find that useful when people do that for me. I do it to my students. I hope they find it useful. I don't know. I haven't gotten any feedback on that. So
one or the other of us is going to get feedback as a result.
Yeah, maybe I'll get some feedback after this episode. So maybe, yeah, that was really useful. I know it wasn't. So yeah, your book is called Dead Simple Python. I don't know that we specifically said that out loud. You mentioned the title a few times. And so from the title, right, like it's to make it simple for people who already understand other languages to pick up Python and kind of gain that deeper understanding. Would that be a good synopsis?
Yeah. You already have gone through the basics of coding. You don't want to be walked through, this is a variable and this is a function and here's how a loop works. Like you probably know those things. Because that's what most of the introduction to Python books are going to spend 2/3 of the time explaining to you is those basics, and that's not something you need a refresher on. I get some questions sometimes about the title though, and the title was very deliberate. I actually had to sell the publisher on the title in the first place. So the idea behind the name Dead Simple Python and the irony that a book called that is an 800-page book is that it's not dead simple looking into it. In Python, we have this thing called the one obvious way. And that comes from Tim Peters, the Zen of Python. But there's this kind of side note he puts in that same little poem where he says that one obvious way may not be obvious unless you're Dutch. In other words, unless you're Guido van Rossum yourself, you may not immediately know what the one obvious way is. And what he's referring to is the fact that obviousness in Python is not looking in. Like looking in, you're like, there's a million ways of solving this. It's retrospective. Once you've solved the problem correctly, you know it's correct because you look back and go, gee, why did I ever think anything else was going to work? That this is obviously the right way to do it. So it's kind of a way of testing your solution after you've come up with it. And I find when I'm writing code, this is actually a pretty reliable test, because if I look back on the code and go, I don't know, I'm still not convinced that's the best way to do it, then it isn't. There's probably a more optimal way to solve the problem. Python is particularly built for this type of thinking, but I have found this applies to most languages. That is, all the languages I've worked with, this kind of applies. It's a really interesting principle that you found the optimal solution when you look back and it just clicks and you go, oh yeah, of course that's the way to do it.
Huh. Okay. Are you, when you're looking, are you trying to see, like, is there a simpler way? Like, is that going through your mind, or is it just like I look at it and I'm like, yeah, that seems about right?
Yeah, it's you're looking at it and you're pondering the various factors, because simple is sometimes good, sometimes complexity is necessary, but you are, I guess you're kind of justifying it to yourself. It's like, okay, I have this extra complex. Let me leave C++, for example, excuse me, try that again. Let me leave Python for a moment to give an example of this in C++. I was writing some code that was going to allow interpreting any sort of data as a string. If you've done any work with C++ or any of its cousin languages, you know that it's very unyielding when it comes to data types. And so you have to write some very complicated code in order to have that same sort of adaptive generic coding that languages like Python give you almost for free. So the code I wrote was very complicated, but I knew it was the best way to do it. In fact, I knew it was the obvious way to do it for two reasons. One is that the results were that it was very simple to use the library I had just written. That it didn't matter what you put in, you put anything you wanted into this one endpoint in the library, and you got a string representation of it accurately every time. The other way I knew it was ideal is because I could add new functionality to that without breaking a sweat. It was just a matter of, 2 lines of boilerplate and plop another function in there, and it worked. So I knew it was the best way because it was obvious. I couldn't think of a better way to do it. The results were perfect, and it was extensible, and I could figure out where I was in the code at any given time. So I knew it was, if not the optimal solution, at least an optimal solution.
Cool. Okay, so earlier you mentioned doing running some internships. You want to talk about MousePaw Media a little bit and what you've been doing there?
Sure, yeah. I started out my career while I was still recovering from my second TBI. And that was interfering with my life to the degree that at the time I couldn't hold down a job, only because I didn't know any given day what my energy level was going to be. I could be doing fine and then just suddenly crash and have no cognitive energy left. So that sort of unpredictability really makes it hard to work outside the home. So I thought, I don't want to wait on starting my career. So, I learned coding because I wanted to build games. So let's build games. Let's just kind of try pursuing this as a career. So I started building my own game, started building my own game engine. Somewhere along the way, I realized that not only was I learning a lot through that process, but that I had a project that was really, really optimal for practicing the skills of a software engineer. And so at the encouragement of one of my computer science professors, I started this internship program with the idea that, look, this is just a 6-hour-a-week thing. You can do it remotely, and it gives you an opportunity to work on a real large project with all of the, because large projects behave differently than example projects. Example projects are nicely little contained Lego models, and that does not scale up to building an actual bridge over the Hudson River. So, there's some similar principles, but largely it's another world. So this was a large and unruly enough project that it was really demonstrating all of the professional skills that were going to be needed to work full-time as a software engineer. So extending this opportunity to people who hadn't yet started coding outside of those little example projects, it gave them a chance to build the work habits and the ways of approaching problems that they were going to need to thrive in their field. And the internship program went through a few iterations. I was working with a couple of universities local to me to help tailor it to complement the computer science programs there. But as it evolved, I began to realize that the people who really needed it were the ones who weren't going to college. They were the people who were changing careers. They were the people who taught themselves software engineering in their parents' basement. They were the ones who had gone to a boot camp or whatever and just didn't have the opportunity to get one of those golden internships at Google or whatever, because Google didn't want them because, well, they don't have a degree. So in a way, it was breaking the paper ceiling by providing this opportunity to people to practice these skills.
That's cool. So as part of that, right, you've also developed this thing called Quantified Tasks. You want to talk about that?
Yeah, so that goes actually all the way back to my first year of coding. But the first programming book I ever picked up was Sam's Teach Yourself Visual Basic.net in 24 hours. The second book I picked up was a book called Dreaming in Code by Scott Rosenberg. Came across it in the library and it looked interesting. And Scott Rosenberg described all of the hazards of trying to develop software, especially any software that did anything novel. One of the things he talked about in that book was this phenomenon wherein certain tasks just took more time than was available in the known universe. It didn't matter how much work you put into that task, it never got done. And that there really was no good way of recording in an issue tracker or a project management Gantt chart or whatever when you had one of these tasks. It was assuming that everything was fairly linear. And in fact, software engineering tasks tended not to be linear.
It's like that long tail of the distribution, right?
Yeah. But sometimes that long tail's before you get it out the door, because it's just like, it doesn't matter how much you try. It's like the bug almost seems to keep moving on you, or the features just, the work keeps compounding. You try to build a feature like, no, okay, that's not working, and that's not working, and that's not working. But he said something interesting. He said, a developer can usually tell you in the first 10 minutes of working on a task whether or not it's a black hole. And I actually underlined that when I got my own copy of the book. I didn't do it in the library. When I got my own copy of the book, I underlined that. It's like, it's a black hole. That's interesting. And I started pondering, what are the clues that a task is a black hole? And this led to the first of several iterations on a way of measuring a task and how much energy it was going to take to complete that task. Because you can make your best estimate based on the way it basically works now is that you look at the task and you ask yourself, if I knew everything, roughly how long would this take me in relation to a sprint? And what resources exist to help me solve this task, documentation, tutorials, etc. And you can take these two scores and add them together to get, kind of a rough idea of how much energy it's going to take. But then you have this degree of uncertainty, which is captured in this metric called relativity. All of these are 1 to 5 numbers. So relativity, you look at it and you ask yourself, how much do we not know? What unknowns are there? And it could be anywhere from relativity 1, which is we don't know of any unknowns. This looks straightforward. I'm adding a button to a web page, all the way up to relativity 5, which is we don't know anything. A great example of this is the doomed attempt by the FAA to get the air traffic controller system rebuilt. They never did manage it because the project just kept ballooning in terms of complexity, and nobody knew how to finish it. There were no knowns there. It was never completable. So once you assess these things, you add your distance and your friction, those first two things I talked about, multiply it by relativity. This gives you a number which weirdly follows the same range and general curve as those Fibonacci numbers everyone likes to use for story points. But it actually is now a justifiable estimate on how much energy this is going to take. And in practice, I've been using this on teams for a number of years now, and in practice, it proves to be a pretty reliable estimate, with the benefit that you're also able to spot those problem areas at a project way out and go, we don't know enough to finish this. Let's stop and recalibrate what we're doing, as opposed to what we've historically done before, which is get into the task, discover it's a black hole, and now you've wasted weeks and weeks and weeks of energy.
Or better, you just keep throwing more effort at it.
Yeah, and hope
you just need more people, and crack the whips harder, and they'll somehow it'll magically work out.
Exactly, and the cool thing about these 3 numbers too is that managers keep wanting to understand story points, and of course, story points are unitless. They're kind of actually, I hate to say it, but they're meaningless. They don't actually mean anything except in relation to other tasks in the same project with the same team.
Yeah, you change the team, you change the project, it doesn't work anymore.
But managers
they're all relative
them
to each other. Yeah, well, I think the story points idea is based on the thought that if we put 2 tasks side by side, we're really good at relative sizing. We're really bad at absolute sizing. So it's really easy to say task A is harder than task B, but how much harder is really hard to tell.
Right.
But twice the size or 3 times the size or 5 times the size, that's hard. But is it bigger? Oh, yeah, it's bigger.
Yeah, but it's also hard to tell when you factor in the fact that if you have a junior and a senior, they're going to have 2 entirely different ideas on what that what the size of that task
Yeah,
is.
yeah.
But they can agree how long it would take if they knew everything. They can agree what resources exist to help you with it, and they can agree on how much is unknown. And so it takes it from this subjective, it would take me such and such amount of time or energy to this objective analysis. And because you're moving from a subjective person-specific assessment to something that is objective, then you have a tool that not only the developers can use, but the managers can use. Because now that manager knows, okay, this is a huge energy point score on this task, but throwing more people at it is not going to solve anything because the reason it's big is because of a high relativity.
Yep.
So we need to rethink how we're approaching this, as opposed to high distance, we need more people.
Ah, that's interesting. So it gives you more insight. Now, do quantified tasks, does that number transfer across groups and teams and projects? Like story points do not do those?
Yes, they do.
Okay.
Because they're all 1 to 5 numbers with very specific criteria, they do transfer across. They're also relative to sprint, so it doesn't matter how long your sprint is. If you've been working on a 2-week sprint team and you move to a month-long sprint team, you can still use those comparisons. The tasks may in fact be, a task with the same score may in fact be bigger on a month-long sprint team, but the reality is you're always choosing tasks in relation to a sprint, not in relation to a period of time. The beautiful thing about that repeatability is that you form a personal relationship to the numbers. So now you can actually go into that estimation with the idea that, okay, this is a language I'm comfortable with. I don't know the framework though. And when I've been in that situation before, I can complete about 25 energy points a sprint. And now you actually have a budget in mind of how much you can commit to. And it holds fairly true. Obviously, you don't have complete control over everything. Something might turn out to have more complexity than you expect. But in general, you can actually find a reasonable amount of work for yourself in that sprint. And those smaller numbers like friction and relativity also help you select things appropriate to your skill level. You might be a senior and thus take on higher friction tasks, or you might be a junior and go, you know what, I'm going to go for the low-hanging fruit, the lower friction task, lower relativity, because I don't know what I'm doing. And that's okay. It allows people to self-select what work and how much work, and learn more about themselves, so when they move to a different project, a different team, they can continue to use that information.
Okay, so if I understand this correctly, right, you're taking those 3 numbers, you combine them, you're getting an energy point, but not all energy points are equal because it depends on how those 3 numbers add up to go into that energy point, right?
Mm-hmm.
Okay,
yeah.
So you're actually dragging around like all 3 numbers, right?
Exactly.
Okay.
Yeah. You always record all 3 because all 3 matter. The other problem with story points has always been that there's no reliable way of recording how we got at that estimate. I've been in Fibonacci sizing things where we're debating like, okay, well, this is a high thing because of the documentation or the lack thereof, but then nobody writes that down. So then the thing sits there in the backlog for 3 months, and then
it comes
you
up,
have 2 people leave, 3 people come in, and then they're like, I wonder why that's going to take an 8.
Right.
Nobody knows.
And then, and if you knew it was because there's poor documentation, you might pick somebody who already knows a lot about that particular subject, right?
Exactly.
As opposed to somebody who knows nothing. Because if somebody who knows nothing, they're going to rely on the documentation that's not there.
Exactly. Yeah.
That's interesting. Yeah, I very much like that idea. So I have a question then though. So you mentioned sprints and stuff. I tend to do more of like a Kanban style thing where we just kind of like organize everything and just pick off the top priorities. Like what value do you see in keeping track of things like that for Kanban and stuff? Is it just like kind of getting a general feel for like how fast you're going, or are there other uses, or how does that work?
Well, there actually is another half of quantified tasks that's related to planning, and it shims in very nicely to Kanban. So the estimation side fits in with Scrum, and then the planning side fits in with Kanban. You can actually use this without Scrum or Kanban, but it works best in those methodologies. So with quantified tasks, there's basically this funnel of priorities. So you start out on again, it's all 1 to 5. So you start out with this impact score, 1 to 5. And I'm not, if anyone's curious, by the way, about this, quantifiedtask.org, I go into all of the details. So we can put that in the show notes. But Impact is the importance of the task you're looking at, whether it's a bug or a story or whatever, to the users of your project. You're recording that once and for all. That's a fixed number, because the next number down is gravity, which is the importance to the release. If you remember the principles of for example, Scrum, they point out that your releases and your sprints must be managed separately, because whether or not something is ready to release may not be chronologically, aligned.
Okay.
So gravity is the importance to the release. Everything from 5 of like, it kind of maps to Moscow almost. Is like 5 is like the must have, and 1 is the won't have. So it's the importance to the release, and that's something that still the product owner has a lot of control over. But then that third level is the priority, and that is related typically to the sprint. But if you're not using sprints, it can also just be kind of a continuous.
Yeah.
It can be a continuous thing in relation to your Kanban board, because it maps to this idea of now, next, later. So priority 4 is stuff that's currently being worked on. Priority 3 is stuff that's going to be worked on next. It's the pool of things that people will pull from. I'm done with the task. What do I work on now? Grab from priority 3. Priority 2 is the stuff that it's either your sprint stretch goals or the stuff that's probably going to be done in the next development cycle instead of this one. Priority 1 is like, it's later. We're not even looking at it right now. Priority 5 is my hair is on fire.
Yeah.
If there's an emergency, drop everything and do this. You always have an escalation pathway. So these 3 numbers form a sort of funnel wherein you are taking the priorities in relation to the whole project, and you're narrowing it down to the priorities for right this minute. And that actually maps really nicely to a Kanban board.
That's interesting. So I used to go to this business development group, and we would talk about business plans and stuff. And it was very much like you set your yearly goals, and then you set your quarterly goals, and then monthly goals, and then weekly goals down to day. And it was very easy then to break that down, and then to also look back up and say, okay, I'm doing this thing today. What bigger weekly or monthly goal am I working towards? And how does that fit into my yearly plan? Which is very interesting. Kind of
exactly. I love using this with epics and stories, because when you have an epic and you give that an impact score, then that impact score on the epic affects the score of any stories or tasks that get associated with that. Because if it's a low impact epic, then the task can never be particularly high impact. You can't really go above the epic's impact, because if it's not an important feature, then sure, it might be a bug that completely breaks the feature, but if nobody cares about the feature, it's just not a priority.
Yeah, I think often software engineers, we fail to prioritize stuff correctly. We fail to understand the user's needs, and we also fail to understand the business priorities a lot. We often operate in our own little worlds, particularly in non-agile type development, the old waterfall style where they just threw things over the wall. Everybody was just like doing whatever they wanted, basically. It's like, I think this feature is important, so we'll go add it. And okay, great, but nobody asked for it, or it doesn't have any business value, so why are we doing it?
Right. Yeah. And that's one of the other reasons why impact kind of got added to quantified tasks, because when you approach it from a product owner or a stakeholder perspective, it's easy to say, well, everything's a priority, but because again, you're dealing with like this 1 to 5 scale, you can really quickly apply the Pareto principle and just go, okay, well, what is important? Because if everything's a 5, then you don't have any clear direction.
Yeah. If everything's a priority, nothing's a priority. And actually, I think we get it all wrong when we make the word priorities plural. It should never be plural, right? Because no matter what you're doing, I think there's always one most important thing.
That's a good point. Yeah.
And you might say these 5 things are important, but if you tell them they have to pick one, it's amazing. Everybody in the room will pick the same one usually, if they're well aligned. It's usually like, okay, yeah, I think this is really important, but man, that's number 1. So
yeah,
it's always
exactly.
Interesting. Yeah.
So something like this becomes a tool that the developers or the project manager or whoever is helping bridge the gap between developers and stakeholders can use to kind of guide that conversation and say, okay, now you have all of these things you want to do, but what actually matters to your users and what matters the most?
Yeah. So I'm curious. So I've done some ranking things in like workshops and stuff where like, you have a scale of 1 to 10, but you're only allowed like 1 10 and 1 0,
Hmm.
and nothing's allowed to be a 5. So you kind of have to make that choice. Do
Hmm.
you ever play around with systems like that? Because like that forces you to say I can have one like thing that I don't care about and one thing that is the absolute priority, but everything else I have to make a decision. Is it above or below the line kind of thing?
Yeah, I hadn't thought of it in exactly that way, but I will say the reason I went with a 1 to 5 scale is because I know for myself, I tend to try and do halvesies. Uh,
Oh, okay.
where it's like, oh, well, if I'm doing a 1 to 10, then I kind of go, I go for the odd numbers. It's like, it's a 7. It's like, no, 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 no. That's very non-committal of me. I
Yeah.
hate, I
Well,
hate that. So I force myself into a 1 to 5 because then I have to commit to this is either really important, sort of important, could go either way, not important, or we really don't care at all.
oh, okay. Yeah, that's actually a good way. I was gonna say I was wondering if you like in my mind I would hit like a lot of 1s, a lot of 5s, and a lot of 3s, and very few 2 to 4s. Right? I would think that people just for whatever reason tend to bin it that way, right? Like it's either extreme or it's like I don't care at all.
Right.
But
Well,
forcing
and
them to kind of like put stuff above or below the line.
yeah, and in quantified tasks, fives are always special. Fives are always a signal that either something is extremely important or extremely wrong. Fives are always an alert in this approach. So when you combine that with the Pareto principle, so the idea being that 5 means that there is no way on earth you can ship this project without this feature. If there's any possibility whatsoever that you could leave it out and still have a viable product, it's not a 5.
Yeah, so that would be a very few features then.
Exactly.
Yeah.
And then 4s generally need to complement the 5s because
Yeah.
if it's a nice to have, it's a bell, whistle, or a gong, it's not important. It can still be left out because 4s are like the last things you cut. That's the framing I like to use most of all with both impact and gravity is can this be cut? And if it can't be cut at all, it's a 5. And if it really doesn't matter at all, it's a 1. Because when you inevitably have too much on your plate,
Yeah, you
then you
have to
use
cut
these
something.
numbers and you cut your 1s, then your 2s, then your 3s, and then finally your 4s.
Okay. No, I like that. Yeah, it definitely gives that prioritization some. Because I do think too, like, if you're thinking in terms of like building like a walking skeleton or something, you build those like core things first and then you just kind of add on them. So you'd start with like the number 5 and get that working and then build out. Or start working towards number 5 and get that working and then build out.
Exactly. Yeah. And then, well,
Yeah.
when you put it in those sorts of terms to a stakeholder, especially one that doesn't have a strong technical background, they it really changes their perspective because then they start going, well, I mean, um, I want this to be delivered, so I mean, I guess you can leave that out. Yeah.
Yeah. Yeah, it gets over some of those waterfall hurdles of like, we put all the requirements together in the beginning. And that's actually my biggest problem with the old waterfall method is there's no priority. You get a requirements document.
Mm-hmm.
A requirements document without priorities, in my mind, is pretty useless.
Mm-hmm.
Because how do you know, like, inevitably people end up spending time on the easy, low hanging fruit that aren't the important things. And you get all those done. And then the one important thing that's really hard, nobody works on because, well, yeah, we couldn't check that off the list.
Yeah.
Yeah.
Yeah, and I was actually asked once if this could work with waterfall because there's some people that are stuck in a mandated waterfall environment. They're like, I want to be able to figure out how much work's involved in things, but we don't use Scrum. Can I use this? You actually kind of can because in a way it's a backdoor agile if you think about it because impact is still assessed up front. So if you're dealing with a company that is very waterfall flavored and they want to assess everything from the beginning, introduce them to this idea of impact, get them to do that assessment, that impact analysis up front, because those are intended to be fixed numbers anyway. I mean, you can change them if you get new information, but if you have a company that doesn't want to change them, fine, have them set them up front, because then it still gives you the ability to say, this matters more than this, and we only have time to ship one, so I don't have to go back to the stakeholder and go, which one matters? And just go, well, this one's got the higher impact, so there we go.
Yeah. You have to be realistic. If you're doing waterfall, like if we get 90% of the project and we get the right 90%, can we still ship it?
Mhm.
And usually the answer is yes. Even though they're like, we want it all, this is what you promised. It's like, well, okay, we'll take 90% and it's still useful and works. And
Right. Because
Kind of like a
most
pragmatic
companies are not
approach.
so silly as to say, well, we don't want to ship a saleable product because we didn't get everything on our list.
yeah, we're missing that one bell or whistle, that one graph that one customer asked for, so we can't ship it. Yeah, no. It's like, yeah. Cool. Well, it's been a great conversation, Jason. I really enjoyed this. Do you have any last minute things that we didn't cover or closing thoughts?
Well, basically just, for anyone who's wanting to pick up Python, check out Dead Simple Python from No Starch Press. And then if anyone wants to learn more about this quantified tasks thing we've been talking about, there's a Substack at quantifiedtasks.org. And the whole thing's documented there. And I add new articles as well periodically. So, subscribe for the latest updates. And yeah.
All right, great. Thank you.
Hey listeners, I've got a very exciting announcement for you. Many of you have been asking, how do I get on an episode? How do I have a conversation with Sam? Well, we're opening that up to all of you. If you go to the contact page on our website, there will be a form that you can submit to put in an application to be a guest on the LabVIEW experiment. We'll have you put in some topics that you're interested in talking about, a little bit about yourself, and we'll contact you from there. We hope to see you on an episode of the LabVIEW experiment very soon.
That's it for today's episode of the LabVIEW experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at @TheLVExperiment.